Hi, welcome back to another discussion on computer network. So, this what you can see on the screen. We have a figure that shows connection of computers, not only computers but also um, devices, wireless devices such as cell phones and tablets. Now, as a review, a network is said to be a collection of interconnected hosts via some shared media which can be wired or wireless. To enumerate some of the terms that we'll be using for the rest of the semester, these are the following. As you can see here, we have the term host is mentioned. It is said to be situated at the ultimate end of the network. So the examples of these are computers, servers, database servers. Okay, so these are hosts. If we're talking about the wired media, then it can be copper cable, fiber optic cable, and coaxial cable. But if we're talking about the wireless media, it can be free-to-air radio frequency or some special wireless band. Wireless frequencies can be used to interconnect remote sites also. Next is the hub. We've discussed this already, but for discussion, it is a multi-port repeater. Okay, and it is used to connect hosts in a LAN segment. Next is the switch. So if hub is a multi-port repeater, a switch is a multi-port bridge and is used to connect hosts in a LAN segment as well. Router is a layer 3 device, which means routing decisions for the data and information sent for some remote destination. Next is gateways. So gateways, these are software or a combination of software and hardware put together, which works for exchanging data among networks which are using different protocols for sharing data. Next is the firewall. Okay, same with gateways. Firewall can be software or a combination of software and hardware and is used to protect users' data for unintended recipients on the network or the internet. Next is host addressing. So as mentioned earlier, what are examples of hosts? These are computers, these are end devices. Okay, so examples are computers, cell phones, servers. Okay, and you need for them to be able to communicate within the network, they have to be assigned an address, and that's why we call it as host addressing. Communication between hosts can happen only if they can identify each other on the network. Okay, and a MAC address is a factory coded 48 bits hardware address which can also uniquely identify a host. So there are actually two types of addressing in computer networking, that is MAC address and Internet Protocol address. Now the MAC address, you cannot change the address because it's hard-coded to the hardware. But for the IP address or Internet Protocol address, this is the one that we configure. That's why they call it as a logical address. Another fundamental concept in networking is the OSI model, or it stands for International Standard Organization, which was well-defined model for communication systems known as the Open System Interconnection, or in short, call it as the OSI model. So in the OSI model, there are 7 layers, and these are the following: application, presentation, session, transport, network, data link, and physical. Now, if we browse through the definitions of those, it's clear that the application layer, or this part here, is stated as the layer number 7. That means we start from the bottom and going to the top. This is layer 1, physical, layer 2, data link, layer 3, network, layer 4, transport, layer 5, session, layer 6, presentation, and layer 7 as application. Okay. In the OSI model, think of the 7 layers as the assembly line in the computer. In each layer, certain things happen to the data that prepare it for the next layer. So the 7 layers which separate it into 2 sets. The first is the application set, which is the application layer and the presentation layer. This is the application set. And then the next following layers, it starts from transport, network, data, and physical, are covered under the transport set. So from the layer 7 or the application layer, in this layer, what actually interacts with the operating system or application whenever the user chooses to transfer files, read messages, or perform other network-related activities. Now here in the presentation layer, it takes the data provided by the application layer and converts it into a standard format that the others can understand. And then under the session 5 or layer 5 is responsible for establishing, maintaining, and ending the communication within the receiving device. Next is under the transport layer. This layer maintains the flow control of data and provides for error checking and recovery of data between the devices. So flow control means that transport layer looks to see if data is coming from more than one application and integrates each application's data into a single stream for physical network. Next is the layer 3, which is the network layer. The way that data will be sent to the recipient device is determined in this layer. So logical protocols, routing, and addressing are handled here. And then in the data layer, in this layer, the appropriate physical protocol is assigned to the data. Also, the type of network and the packet sequencing is defined here. And finally, in the physical layer, this is the level of the actual hardware. It defines the physical characteristics of the network such as connections, voltage levels, and timing. So when it ends here, it begins, and when it reaches to the other end, to the receiver's end, it starts again from the physical data link and so on and so forth until it reaches the application layer. The Osi Reference Model, which is this one, is actually just a guideline where the actual protocol stacks often combine one or more of the Osi layers into a single layer. So protocol stacks, this is a comparison between the TCP/IP model and the Osi model. So a protocol stack is a group of protocols that all work together to allow software or hardware to perform a function. And then the TCP/IP, which is this one, is an example for that. It uses 4 layers that map the Osi model as follows. So in the layer 1, which is the network layer, this layer 1 is a combination of the physical layer of the Osi and the data link layer. And it routes the data between devices on the same network. It also manages the exchange of data between the network and other devices. Now layer 2, which is the internet layer, this layer corresponds to the network layer. The internet protocol uses the IP address consisting of network identifier and host identifier to determine the address of the device it is communicating with. So that is for the internet layer. Next is layer 3, which is the transport layer. This one, corresponding to the Osi transport layer as well, is a part of the protocol stack where the transport control protocol can be found, or the TCP. Now TCP works by asking another device on the network if it is willing to accept information from the local device. Next is the layer 4, which is the application layer. In this layer, it combines the session, the presentation, and the application layers of the OSI model. The protocols for specific functions such as email, simple mail transfer protocol or SMTP, and file transfer protocol resides in this level. As you can see, it is not necessary to develop a separate layer for each and every function outlined in the OSI reference model, but developers are able to ensure that a certain level of compatibility is maintained by following the general guidelines provided by the model. Okay, so these are the descriptions and definitions, short definitions of the various layers. Layer 7, 6, 5, 4, 3, 2, and 1. That is for the OSI model. Next is for TCP model, TCP IP model. Here. Next is the packet structure. Now, data that passes through the network is, so the Internet Protocol, being a layer 3 protocol, takes data segments from layer 4 and divides it into packets. So the IP packet encapsulates data unit received from the above layer and add to its own header information. So this is what the packet would look like in a dissected form. So encapsulated data is referred to the IP payload. IP header contains all the necessary information to deliver the packet at the other end. So your packet contains this metadata. Your packet in itself has data. So the version is the version protocol. IHL is the Internet Header Length. DSCP, Differentiated Services Code Point. This is a type of service. ECN, Explicit Congestion Notification, and it carries information about the congestion seen in the route. Total length refers to the length of the entire IP packet, and then the identification is IP packet is fragmented during the transmission. Under the flags, these are required by the network resources. If IP packet is too large to handle, these flags tells if they can be fragmented or not. In this 3-bit flag, the MSB is always set to 0. Fragment offset. This offset tells the exact position of the fragment in the original IP packet. Time to live. To avoid looping in the network, every packet is sent with some TTL value which is set, which tells the network how many routers or hops this packet can cross. If you can still remember it in the activity that we had using the ping, there's a part there where you can see the TTL or the time to live. Next is protocol, which tells the network layer at the destination host to which protocol this packet belongs to. Next is the header checksum. This field is used to keep checksum value of the entire header, which is then used to check if the packet is received error-free. The source address, 32-bit address of the sender of the packet. Destination address, the 32-bit address of the receiver, and then these are the IP addresses. Okay, source address and destination address. Options, this is the optional field which is used if the value of IHL is greater than 5. Okay, so these are the following information that goes with the packet when it is sent through the network. Next is types of addressing. Okay, IPv4 or IP version 4 supports the 3 types of addressing: unicast addressing, broadcast, and the multicast addressing mode. So the first one, in the unicast addressing mode, in this mode, data is sent only to one destined host. So only one. The destination address field contains 32-bit IP address of the destination host. Here the client sends data to the targeted server. Okay, so from the client to the server, that's a unicast addressing. Example of unicast addressing. Next is the broadcast addressing. In this mode, the packet is addressed to all the hosts in a network. So the destination address field contains a special broadcast address, example 255.255.255.255. When the host sees this packet on the network, it is bound to process it. Here, the client sends a packet which is entertained by all servers. So the client sends data to the network and is entertained by all the servers because we are in the broadcast addressing mode. Next is in the multicast addressing mode. The mode is a mix of previous two modes, which is the unicast and the broadcast. In this packet, the destination address contains a special address such starts with 224 variable xxx and can be entertained by more than one host. So a client sends, and then there's a combination already of the unicast and the broadcast addressing mode. Here, the server sends packets which are entertained by more than one server. Every network has one IP address reserved for the network number, which represents the network, and one of IP address reserved for broadcast address, which represents all the hosts in the network. So this is hierarchical addressing scheme, which the IPv4 uses. This is what we used in our laboratory in Packet Tracer. Because to remember the 192.168.1.2, a single IP address can contain information about the network and its subnetwork and ultimately the host. This scheme enables the IP address to be hierarchical, where a network can have many subnetworks, which in turn can have many hosts. For this session, we will end and we're going to continue on the next video. Thank you guys for taking time to listen to this video. Have a nice day. Bye.